Greetings, grade 12s, mathematics. Today we are going to be looking at the exponential functions, of which they only have the horizontal asymptote. They are not like the hyperbola graph, of which they have the horizontal and the vertical asymptote. This one has got only horizontal asymptote. This is a positive graph. For the exponential graphs, this is a negative graph. You can see it goes down the y values. This one, the positive one, goes up the positive y values. So this is how you memorize, and how it starts. You memorize with the horizontal asymptote. The horizontal asymptote is this line where the graph starts and goes up if it's a positive graph. And also here, this is a horizontal asymptote whereby the graph start from going downwards if it's a negative graph. Let's just take a simple example. We can have y equals to 3 to the exponent x. This is an exponential equation. Then for this one, our HA, which is the horizontal asymptote, will be equals to 0 for this one. Then you want to get some 2 points so that you can be able to plot the graph. What are those 2 points? How to find them? This is x and this is y. Then to find the first point, you need to say that x is equals to 0. You always say that x must be equals to 0 first. And then the second one will be that x will be equals to 1. Always x is equals to 0 and x is equals to 1. For which x? This x here as an exponent, you should make it equals to 0 first, and secondly you make it equals to 1. Then because of that, now we've got x equals to 0 and x equals to 1. Then since we've got x equals to 0, which is here, and x equals to 1, which is here, now we have to find the output values, which are y values. To find that, we have to substitute these values, the input values from the original equation, these two input values, to find those two output values. Then we say y equals to 3 to the power x. Then y equals to 3 to the power 0, right? 3 to the power 0. We substitute this 0 here and we have 0 here. Any number to the power 0 is equals to 1 always. Where there is 0, we put 1. And again, we substitute what now? Now we're substituting 1 from the same equation. Then we will say y equals to 3 to the power x. Then our y will be equals to 3 to the power 1 now. 3 to the power 1, which is y equals to 3. 1 to the power 3 to the power 1 will be 3. Then we've got 3 here. Then once we have these 2 points, then we are able to plot the graph. Our graph will be like this. We've got 1, 2, 3 on the y values, and on the x values we've got 1. We can say 2. Our HA will be 0. So let's go ahead and label that one. You can see that I've tried to draw a yellow dotted line which symbolizes the horizontal asymptote as being 0. Our horizontal asymptote is 0. Let's look at our points now. Where there is 0, there is 1. Where x is 0, y will be negative. Y will be 1. Where x is 0. Where x is 1 now, y will be equals to 3. Then where x is 1, y will be equals to 3. Okay, the most important thing before you plot the graph, look at this example here of the positive graph. Is it must go up the y values. It doesn't have to go down like this. It must go. You just look at the formula. You just look at the equation. If here there is a positive sign, then the graph must look like this. If here there is a negative sign, then the graph must be like this. Once you have a positive sign here next to 3, and your graph directs you to go like this, then there's something wrong in your calculations, or maybe something wrong with your equation. So you have to be careful of that. So just because we've got a positive equation here, then our graph will go like this one, and it will be like this. Now that's our graph now. The domain for the exponential function, it's like the quadratic functions, whereby the domain is always from the negative infinity to positive infinity So it's always negative infinity to positive infinity. Why? Why do we say that? We're not just saying it. Just look at the x. These are the x's. It's from negative infinity. We don't know negative what from there. It's from the negative infinity. The graph goes until positive infinity. We don't know which value, biggest value, it will end that side. So it's from negative infinity. Because domains are for the x's, right? From the minimum point of x values to the maximum point of the x values. For y values now, the minimum y value that we have is 0, because this line starts from where the y is 0, not y is negative or something. Here we know that our HA is 0. So always the minimum, if it's a positive graph, then the minimum value of the horizontal, the minimum value of y-axis will be equals to the HA, the horizontal asymptote, of which in this case it's 0. So it starts from 0 for y values up to the infinite. We don't know where it ends up there for y values, right? Now then we can say, now we put this square bracket because it's where it starts. It's where we are sure it starts. It's from 0 up to positive infinity. Why 0 from infinity? From 0 here up to we don't know, right? Those are the domains and the range for this particular function. Maybe we can also do the negative one so that you'll be able to see. Now you know that the positive one will go like this. Now let's do the negative one just in terms of 3 to the power of x, like the one we did previously. So now it will be y equals to negative 3 now, negative 3 to the power x. We now want to see if the graph will be like this. Our HA also will be equals to 0. This is x and this is y. We say x must be equals to 0. Always x must be equals to 0. And secondly, x must be equals to what? 1. We've got 0 here and 1. Then we substitute these two input values from the equation to find the output values. Then we say y equals to negative 3 to the power of x. Then we say that negative 3 to the power 0 will not be 1 in this case. It will be negative 1. Anything to the power 0 is 1. And in this case, it's negative 1. So here we've got negative 1. And again, we've got y equals to negative 3. We're substituting 1 now to the power x, then equals to negative 3 to the power 1 on top. The answer is negative 3. Anything to the power 1 is just that thing. So we've got negative 3 here. Here we've got y equals to negative 1, y as negative 2, and y as negative 3. Then we've got x equals to 1 here. Now let's draw the horizontal asymptote, and then we've got 2 points where x is 0, y is negative 1. Then where x is 0, y will be negative 1. And then where x is 1, y it will be equals to negative 3. Where x is 1, y will be negative 3. So our graph will go like this. Our graph goes like this. You can actually see that this is our negative graph, negative equation here. It's a negative one, and it must be like this one because this is a negative graph. It must be like this, not like this, right? I think it's clear. Then we go to the domains and the range. The domains are always from negative infinity to positive infinity, from negative infinity to positive infinity. In this case, for the range, where is the minimum value of y here in this graph? One will say it will start from the horizontal asymptote, and it's wrong. This is the maximum value of y. The minimum value of y we don't know, because it starts from infinity negative of y values. So we start from infinity now to up to the horizontal asymptote where it ends. It's not like here. Here it started from we said it started from 0 to infinity, because it started from the minimum value was from 0 up to positive infinity, of which we don't know. And here the difference is it will not start from the horizontal asymptote, because it's where it's in its maximum point. Then from the negative infinity, it's the what is the lowest point. Then that is why we will say now from negative infinity up to 0, that's where it ends. Now that's our domain and our range. And also remember that our range is y and our domains are x values. I think it's clear. We move to another example. Now suppose that we've got y equals to 4 to the power x plus 1 minus 1 here, minus 1. Right, now we were just saying on the previous ones, we were just saying the horizontal asymptote is 0. Now we start to have a horizontal asymptote now as negative 1. Why do we say our horizontal asymptote is negative 1? It's because now there is something here which is negative 1. It can be plus something or negative something. But the previous, it was just negative 3x, and there was no plus what here. So the HA was 0. So here there is negative 1, minus 1, right? So now we've got the horizontal asymptote as negative 1. We write that down, and remember we said that the exponent here, the exponent must always be equals to 0 and then be equals to 1. Then first of all, we'll say x plus 1 equals to what? Equals to 0 first of all. And then x will be equals to negative 1, because we transpose this one to the other side of the equal sign. This one will go here, and it will become negative 1. And then also we will say that x plus 1 equals to 1 now equals to 1, because we start by saying equals to 0 and equals to 1. It's like here we say this exponent must be equals to 1 firstly, and sorry, it must be equals to 0 firstly and equals to 1. And here it's not just x equals to 0, it's x plus 1 equals to 0, which will give us negative 1. And here it's x plus 1 equals to 1 now, of which it will give us 0, because x is equals to 0. Why? It's because when you take this one to this side, it becomes negative, and 1 minus 1 is equals to 0. Why are we doing this? We are doing this for the benefit of having a table here. Our table will be like this. This is our x, our y, right? Then here we put this negative 1 and this 0 here. So it's negative 1 and also 0 here. Then we substitute the same the input values to find the output values from the original equation. Then we will say that y will be equals to 4 in power x plus 1 minus 1 here. 4 to the power negative 1, where there is x we put negative 1 plus 1 minus 1. So negative 1 plus 1 is 0. So it's 4 to the power 0, of which is anything power 0 is 1. You have to know all those things, that anything to the power 0 let's, for your benefit, let's just put this 4 to the power 0 minus 1. So then it will be 1 minus 1, which means our y here will be 0. Our y will be 0. Then we substitute 0 again. We again substitute 0 here from the original equation. Then we will have again y equals to 4 to the power of x plus 1 minus 1. Right, then equals to the 4 to the power, where there is x we put 0 plus 1 minus 1. 0 plus 1 on top here. When we say 0 plus 1, it will be 1. So it's 4 to the power of 1, which is 4. 4 minus 1. 4 minus 1, it must be 3. Our y will be 3 here, and we put 3 here, right? Then having those 2 points, we are now ready to plot a graph. 1, 2, 3, here it's negative 1. Our horizontal asymptote will be negative 1 here. So let's draw it now. Now that's our horizontal, or our HA, as negative 1. HA is negative 1. Then it's where the graph will start. And the graph is a positive graph. You can actually see it's a positive graph. And we expect a graph like this that will start from, it must start from the horizontal asymptote upward. So always it starts from the dotted line, like it did here. It was starting from the dotted line, and also here it was starting from the dotted line, right? Then for here, let's go to the, let's find the points where there is negative 1 for x, it's 0 for y. So it's here where there is negative 1 for x, y is 0. Then where the x is 0, y will be 3. Then that's the point, y equals to 3. Then the graph will go like this. That's how our graph will go. This is a positive graph, as you can see, because it's positive here. What about the domains and the range? The domains are always, the domains are from negative. There is a negative here, negative infinity to positive infinity. What about the range? Because it's a positive graph, the range will start from negative 1, you can see here, up to infinity. From negative 1 here, that's the lowest point of y values here, negative 1. And up to infinity, we don't know up to positive which y value, right? I think it's clear for this one also. Okay, now I want us to look at some problems, just 2 problems, and then we close. So 2 problems of which they have an e-base, because sometimes you will find some problems with the e-base, and I'll tell you the constant value for the e-base that you are going to be using always when they give you an e-base. And it's very, very easy. It's just like any base they can give you, but this one is an e base with the only difference is that it is having a constant value. Now we start by writing down the e value. The e value will be equals to, always just make it simple and say 2,7, just to make it simple. That's our constant value for e base. Let's start by the example that will be a positive graph. Right, let's say we've got y equals to e now, to the power of x minus 2, then minus 2 also. First of all, let's just write the HA, the horizontal asymptote. We've got our horizontal asymptote here also. And I think you know it by now that our HA is negative 2. Then we write it here as negative 2. Then what we are going to do now, we are going to deal with the exponent, and we will make it equals to 0 first and equals to 1. Let's do that. X minus 2, firstly it will be equals to 0. Then our x will be obviously be equals to 2. Same x minus 2 now equals to 1. Then our x will be equals to, we take this 2 to the other side. 1 minus 2 is equals to 3. and this is our y. Then we've got 2 and 3. We've got 2 and 3. Then when we substitute from the original equation, we will say y will be equals to e to the power x minus 2 minus 2. What is our e? Our e is 2,7 to the power 2 minus 2, because we put this 2 here where there is x. Then 2 minus 2 will be 0. It's to the power 0 minus 2. So our y here will be equals to, okay, here anything to the power 0 will be 1. So 1 minus 2 always is, obviously it will be negative 1. So here it's negative 1. And again, we substitute this 3 from the original equation and say that y will be equals to e base to the power x minus 2 negative 2. Remember, this 2,7 is a constant value. 3 minus 2, which is 1, then power 1 minus 2. So anything power 1 is just 2,7 minus 2. The answer is 0,7. Answer will be 0,7. Once we find 2 points here, then we are able to plot the graph. 1, 2, and 3. For y values, we've got negative 1 and okay, there's 1 here. Let's just say here it's 0,7. 0,7 is here. What is our horizontal asymptote? Our HA is negative 2, as we know that HA is negative 2. Then we just have to label it first, negative 2. Let's try and draw that dotted line for the horizontal asymptote. Where x is 2, y is negative 1. Then where x is 3, y is positive 0,7. Where x is 3, y is positive 0,7. Remember, this graph is a positive. The equation was positive here. Next to e is positive. So we expect a graph like this. Before you start to draw a graph, go to the equation, check if it's positive or negative, and expect something like this. Once the points lead you to draw it like this, then there's something wrong with your calculations or the equation. Always remember that. Our graph will start from here and go like this. Now that's our graph. You can see it's a positive graph. So now let's just do the last one with the e base, but with a negative now, just for your benefit. Y equals to 2 minus e. They will trick you like this, to the power x minus 1. Okay, here they are tricking you, like, a little bit. Where do you see that the graph is negative? Just next to e, just next to the base. The base is the number that is to the power something. Where there is next to the base here, it's where you can read that the equation is negative. Even if this 2 is positive, but this 2 is like this one. This 2 is like this negative 1. I could take this negative 1 and put it here before 4. And the fact that 4 is positive, even if negative 1 will start here, and then maybe it's negative 1 plus 4 to the power x plus 1 plus 1. But if the base is positive, then the graph is positive. Same thing applies here. You just look at the base. You don't look at the constant value. The constant value is just there, but the most important is the base. So which means you can even write this equation like this if you like. You can change it to be like this. If you like, you can start by the base now and say to the power x minus 1, then plus 2. You can see now that this 2, you put it at the end, like here, like negative 2 here. All right, but let's just continue with this one here. We can do it like this, or we can choose this one. It's just one and the same thing, but let's just use this one now. So what is our HA? Our HA is equals to a positive. HA is equals to a positive 2. Then we say x will be equals to 1, and also x will be equals to 2. Why do we say that? It's because we said x minus 1 will be all equals to 0, and x will be positive 1, and then x minus 1 equals to 1. Then we'll transpose this negative 1 to the other side of equal sign. Then it will be positive 1 plus positive 1, which will give us 2. You can do those calculations for yourself. We've been doing it for so many times now. We've got x here and y here. We've got our x being 1 and x being 2. Now we can be able to substitute these two input values from the original equation. You can take this one or this one. Let's take this one and say y equals to 2 minus 2 comma 7 to the power x minus 1. When we put 1 here, it will be 1 minus 1, which is 0. 2 comma 7 to the power 0 here. Then we will say 2 minus 1. Why do we say 2 minus 1? It's because anything to the power 0 is 1. So the answer here will be y equals to 1. So our y will also be equals to 1. And then we substitute also 2 and say y equals to, same equation, 2 minus 2 comma 7, which is our e base, to the power of x minus 1. Then 2, and then here when you put 2 here, put this 2, it's 2 minus 1, which is 1. So it will be 2 minus 2 comma 7 here, negative 0 comma 7. So here it's negative 0 comma 7. So once you have 2 points here, then you can be able to draw your graph. Right, we've got 1 and 2 here, and we've got 1 and 2 here. Our HA is positive 2. Positive 2. That's our HA. Then where there is 1, there is 1 also. So the point is here. 1 is to 1. Where there is 2, there is 0 comma 7. Alright, the graph will go like this now. Remember, it's a negative graph. Negative graph must go like this. I think it's clear. And for the domains, same thing for the domains, from negative infinity to what? To positive infinity. For the range, we start from where there is a small value of y. It's from infinity to what? To positive 2. So our range will be from the infinity, from negative infinity to positive 2. That's where our y values, we are sure they are ending. So thank you for watching.